All right, for this one, we are given events A and B that are mutually exclusive, which means the intersection, the probability of their intersection is equal to 0. That means the addition rule, which is probability of A or B, is given by probability of A plus probability of B, just like that. Now, having that being said, we are to calculate the probability of B. If probability of B is equal to 2 times probability of A, and probability of A or B is equal to 0.57. So that means we have probability of A or B, which is equal to probability of A plus probability of B. This is the addition rule for mutual exclusive events. Now, probability of A is given by 0.57, so we put 0.57 in the place of it. Then probability of A, unfortunately, we don't have so far. Then probability of B is given by 2 times probability of A, which means we have 2 times probability of A. Now this is what we have. So on that note, probability of A plus 2 times probability of A is 3 times probability of A. We have 3 of them. So this is equal to 0.57. So if we can just divide this by 3, then you will get probability of A being equal to 0.19. Okay. Then after having probability of A, you will remember that it was given that probability of B is 2 times probability of A. Then therefore probability of B is going to be 2 times probability of A, which is that. Then therefore the answer becomes 0.38. So this is just what we have for this question. See you in the next one. To the second question. The second question, we're given that the events A and B are independent. Then probability of A is 0.4, probability of B is 0.5. Then we are to determine the probability of A and B. For independent events, remember the product rule. That means we have probability of A and B, which is equal to probability of A times probability of B. For them to be independent, which means the probability of their intersection must be equal to the product of their probabilities. So that means now we have 0.4 times 0.5, which is going to give us 0.2. Yes, that is 0.20. That is just that. So this one is now 0.2 for independent events. So coming to the second one, it says probability of A or B. Probability of A or B for independent events, which means you know that probability of A or B is equal to probability of A plus probability of B minus probability of A and B. So this is B. Yeah. So now probability of A is 0.4, then plus probability of B is 0.5, then minus probability of A and B, which is the one that is calculated there, which is 0.2. So probability of A or B for independent events, then it's going to be 0.7. So that is just what we have for this one. So this is 0.7. Now, let's come to the third question, which now it reads as follows. Determine the probability of not A and not B. Probability of not A and not B, which means if we can just graphically draw our Venn diagram, that we have probabilities. We have A here, we have B here. This is A, this is B. Then if we look at the probability of the intersection, is 0.2.
And if we look at the probability of A itself, this is this one, or which means this is the whole thing, which means if this whole A is 0.4, is what? It's 0.4, which means having 0.2, we are left with 0.2 there, so that 0.2 plus 0.2 give us 0.4 there. Then number B, then probability of B, we have 0.5 there. So to get 0.5 here, we have 0.2 plus what? To get 0.5, we need 0.3. So this is what we have. So now you can see that 0.2 plus 0.2 is 0.4, plus 0.3 is 0.7. So that means we do have the what? The external one, which is 0.3 there, to get everything to be equal to just 1. Now we have those who did not participate in A nor B that are lying outside these two events, which is the complement of these two events. Now we are looking for the probability of not A and not B. So it must not be in A and not in B, right? So that means it has to be this one. But nonetheless, probability of not A is the probability of this intersection, which means let's say not A and probability of not B. So we have that. So that means it's the probability of not A times the probability of not B times the probability of not B. So we have probability of A complement and probability of B complement. So if we can write them up, we are having probability of not A, which means the value that we have must be in this Venn diagram, but not in this Gunguluza, which is A, which means now it's going to be this one and that one that lies outside A, which is 0.6. Then times probability of not B. Probability of not B is this outside thing of B, which means 0.2 plus 0.3 is 0.5. So we have now 0.5. So if you can just multiply both of these things, you will of course get 0.3, which is this one, which is outside, which means now probability of not A and not B is just the outside participants that are found outside these two events, which is just 0.3. So on that note, it can also be found by saying we have probability of A prime and probability of B prime is the same as probability, it's just same as 1 as the what? The lump sum of probability minus probability of A or B, which is now gonna be what? 1 minus 0.7, which is going to give us 0.3. So this is another way of approaching it if you really don't want to use Venn diagram. So that means now it's just now the intersection, which is outside what? Outside these two events, which is going to be this 0.3. So it is done. Let's move to the next question. Bye. Question 9.2. For any two events A and B, it is given that probability of A and B is equal to 0.12 and probability of A or B is equal to 0.83 and probability of B is equal to 4 times probability of A. So we have that information. So now the question says, are the events A and B mutually exclusive? Justify your answer. For mutually exclusive events, we know that probability of A and B, they have to be equal to 0. So now we can see that probability of A and B is not equal to 0 here. So which means the probability of A and B are not mutually exclusive. Hence, the probability of A and B is equal to 0.12. So which means to answer this one, we can say no, they are not. They are not mutual exclusive. Why? Because the probability of A and B are not equal to 0. So that means they are not mutually exclusive because the probability of their intersection is 0,12, which is non-zero number. So done with the first question. Then the second one, it says calculate the probability of B. Calculate the probability of B. But you will remember that we are given the probability of A or B there, that we know that the probability of A or B is given by probability of A plus probability of B, then minus probability of the intersection. So we have this information. Now let's do substitution. Probability of A or B is given by 0,83. So probability of A or B is given by 0,83. Then probability of A, we can say probability of A, we can solve A here, probability of A there, because now we can just divide by 4, then by 4, so that you know that the probability of A will be probability of B divided by 4. So which means in the place of probability of A here, we have used this equation. We are going to put probability of B over 4. Then here, in the place of probability of B, we can put in the place of probability of B, we can just put probability of B, because now we want to solve probability of B, as you can see in this question. So that means in the place of A, in the place of probability of A, we just substituted, or we just first solved probability of A here by dividing by 4 to get probability of B over 4. So this is what we have. Now, subtract the intersection, which is what now? Which is 0,12. So we have 0,12. So on that note, let's just work on this one. Then for this one, we are having 0,3883, then plus 0,12, which is just 0,95. This is equal to, then we have probability of B, then over 4, then plus probability of B. So you can just solve this one, which is going to be 4 plus, which is now, we have 4, then we have 5, probability of B over 4, which is equal to 9 over 5. So we have this kind of situation. So we can just multiply by 4 throughout, so that we have 0,95 times 4, which is going to be 3,8 is equal to 5 times probability of B. So probability of B now, when you divide by 5, you will just get 0,76. So this is probability of B, having used all this information that was given there. So which means, yeah, that is it. So on that note, we can also focus now on probability of not A. Probability of not A is to find what is probability of A first, which now is going to help us to find the probability of A, that we have what? First, the probability of A. Let me just drop this one. Probability of A is gonna be, we know that probability of A or B is given by 0,83, then which is equal to probability of A. We are looking for it, probability of A. Then probability of B is 0,7 6, then minus 0.12, which is the probability of the intersection that was given right in the equation. So now let's find the probability of A now. Probability of A by saying 0.95 plus 0.12, then minus 0.76. So that is our probability of A, which is 0.31. So to find the probability of not A, we are going to say probability of not A, because we are looking for the probability of not A here. Probability of not A, which is probability of A complement, is equal to 1 minus probability of A. Okay, so this is now probability of not A is 1 minus probability of A is 0.31. So now the answer is 1 minus 0.31 is just 0.69. So this is probability of not A now in this case. So we are done with this one, and we are familiarizing ourselves with all these kind of situations, so that at the end of the day we use them with with confidence. Thank you. See you in the next question. Bye.
M and K are two events, and probability of K is equal to 0.5. Probability of K and M is equal to 0.2, and probability of not K and not M is equal to 0.3. So this is the information that is provided to us. Then 9.1.1 says draw the Venn diagram to represent the above events. So we need to represent this information into a Venn diagram. So the Venn diagram is going to be something of this kind. We know that the probability of an event of this whole thing must be equal to 1. So everything that is just should be inside this event, this sample space must be added up to just 1. So now we have the event M and event K this side, and you can see that the probability of their intersection is 0.2, which means 0.2 would be right in the middle. Then probability of K, which means probability of K is 0.5, which means now this circle of K, this circle of K must give us 0.5 when we add 0.3 over there. So which means the whole circle must add up to 0.5. Then we have now probability of not A, not K, and not M which is equal to 0.3. That means 0.3 must be found outside these two events, 0.3, because probability of not K and not M is 0.3. So this is what we have. So we need now to get into 1. If we add 0.3 plus 0.3 plus 0.2 is going to be 0.7. Then this is 0.8. Then therefore we need 0.2 to get just 1 as the sum of all the probabilities of these events. So we have that. So we have already now drew and represented that information into a Venn diagram, just like that. So the second question says, are the events M and K independent or not? Then you explain. So for them to be independent, that means the probability of their intersection, probability of M and K, we know that it is equal to 0.2, right? So this is just what we have right over there. So now we need to find the product of the product of their probabilities and check whether it is going to be 0.2. So let's find the probability of M times probability of K and see what is it gonna give us. Probability of M is 0.5 times probability of K. Probability of M is probability of M is 0.4, because we have to add this 0.2 and that 0.2 over there. Sorry for that. and that's 0.2 over there. So which means the whole circle of M is 0.4, which means we have 0.4 times the probability of K was given initially, which is 0.5. Then we have 0.5. Then the answer is just gonna be 0.2. 0.2, because 4 times 5 is 20. Then therefore 0 times 0 is 0. So we just have 0.20. So which means now we can conclude to say event M and event K are independent, because the probability of M and K is equal to the product of their probabilities. The product of their probabilities. So if the probability of the intersection is called the product of their probabilities, because now we have 0.2, we also have 0.2, so they are equal to each other. So now these two events are independent to each other because of that thing. So thank you guys for watching this one. See you in the next question. Thank you. Bye.